Hello. So the four organisms that I was intentionally working with this summer were the three fungi, Magnaportha oryzae, Rhizoctonia solani, and Clariredia jacksoni, and one actinobacteria, Streptomyces silicolor. As the name suggests, Magnaportha oryzae is the fungus that causes rice blast, but it has also been seen as a pathogen with similar symptoms in other staple cereal crops. These infections can severely impact harvests, posing an economic and dietary threat. Hosts can vary among subgroups in the species, but overall, Rhizoctonia solani, our second fungus, can harm a wide variety of hosts, many of which are of great economic importance, like crop grasses and legumes. Among their hosts, Rhizoctonia solani is responsible for a number of root and foliar rots and blights, like brown patch, damping off, root rots, and sheath blight. Clariredia jacksoni is the fungus responsible for the dollar spot disease, so I refer to it as dollar spot out of habit. Dollar spot is a disease most notably affecting turf grasses. It's an unsightly and expensive problem to manage. Streptomyces silicolor is an actinobacteria, and like other members of its genus, it is a mycelial bacteria known for its many secondary metabolites. Biological control agents have been and continue to be investigated as potential alternatives to traditional chemical pesticides in order to avoid or reduce the downstream environmental impacts that they do bring. So, with our Streptomyces silicolor producing a lot, the general idea behind the project is, could Streptomyces be used as a biocontrol agent for these three fungi? It's still early days, so I started out with simple direct assays. For my first round of experimentation, my procedure was mostly based around, albeit with slight modifications, a procedure used by one of our lab members, Sharon Carr, in a fungal assay with a different bacteria against dollar spot. The first round was just testing direct inhibition. I would take little 5mm fungal plugs out of a plate I had just to grow the fungus. I would take those plugs, place them in the center of new clean plates, and then a few millimeters from the edge of the plate, I would place a disc of filter paper, which was either left as is or inoculated with 20 microliters of a suspension of the Streptomyces. I worked in sets of 5, so for each fungus there were 5 control plates and 5 treated plates. I would then photograph the plates daily as the fungus and or bacteria grow, looking for any differences between treated and untreated plates. The Rhizoctonia plates grew quickly, but in this first round I didn't really see any inhibition of the plates. It would just grow over the discs whether or not they were treated. The dollar spot also grew pretty fast, and similarly, I didn't see much inhibition. It would just grow over the paper discs regardless of treatment. The Magnaportha was much slower growing than the other two fungi, so it took a while to document all this, and even for the fungus to just reach the disc. The slower growth did give the bacteria much longer to grow and establish itself before the fungus would hit it, which might have been a factor in its performance against the other fungi, them not having enough time to get going. However, something similar happened in all the Magnaportha and Streptomyces plates. There was additional growth that wasn't really growing like Streptomyces, even though there was still some red pigmentation that we'd see later that would indicate like there was Streptomyces there, but it wasn't a pure culture. So due to this contamination, I called an end to this first round, but I held on to the plates. Sometimes later, I would occasionally return to check on these plates that I didn't throw away to see how they're developing, and over time, all but plate B became much more like Streptomyces, and even started producing colorful products into the surrounding agar. In these cases, I did see some level of inhibition of the fungus, either as a defined physical gap between the colonies, or by the fungus just not growing over the colonies or disc as they had in the control plates. This is really interesting and something I do want to follow up on, but it's tricky because I know it's not a pure culture, but I'm not sure what the second mystery bacteria is, or what role it played. I ran the experiment again, but with some slight changes to my procedure, having learned from the first try. This time I didn't use paper discs. Even autoclaved, the paper is a needless point of potential contamination, and pipetting directly on the plates works just as well, as long as you let the plate dry a bit before you close it up so that it doesn't drip around. I started the inoculation droplets much closer to the initial fungal plugs, the thought being that this would let the overall experiment run faster, though I didn't set the droplets a uniform distance apart, wanting to see if the distance might make a difference. Instead of adding nothing, I put droplets of PBS. It's the same buffer solution that the silicolor suspension was made in on the control plates. I also started another set of plates, but these had dividers in the middle so that the agar from either side wasn't directly touching. Since Streptomyces do give off volatiles, this was designed to see if those might have an influence on the fungus. Like in the first go-around, the Rhizoctonia and dollar spot didn't seem to have been affected by the Streptomyces. The results for this second round of Magnaportha plus Streptomyces have been the most interesting by far. I've been seeing the same contamination issue that was in the first set. There's some other bacteria present with a growth pattern unlike Streptomyces, but the Streptomyces hasn't died and seemed to just be growing or staying on top of the contaminant. Again, this mystery combination does seem to be influencing the fungal growth, and while there isn't a zone of inhibition, the Magnaportha is not growing over the bacterial zone. something interesting is happening, but I'm not quite sure what or why. Even though my trials haven't been going as I had hoped or expected them to, and they haven't really given me much clean data for the Magna Portha, what I have been seeing has been inspiration for redesigns in my research and new points for exploration. I will be continuing this project as we go into fall, and some of the most immediate things I do want to try are trying to give the Streptomyces more time to get established and seeing if that makes a difference, either by taking plugs out of bacterial lawns instead of just using a suspension, or by inoculating plates, but giving them time to develop before I add the fungus. I want to investigate using just the exudates of the Streptomyces from when they're around the fungus, maybe either by collecting the agar that's been colored so that the Streptomyces have been making something there, and then heat treating it or filtering it to kill off any live Streptomyces. I also really want to try to figure out what it was that I was growing, what that second bacteria was. If I can figure that out and get isolates, I'd like to run those in their own fungal assays, since maybe they themselves are inhibitory. So I don't know if it was the intentional or the unintentional bacteria that was working here, or if it's both, or what's going on there. I do suspect that the contaminant was some kind of bacillus. So there's a Bacillus subtilis strain called ED1022 that we work with a lot in the Bais lab. So I would like to try that against the Magna Portha and Rhizoctonia. Before I go, I'd like to give my thanks to everyone who made the Summer Scholars and Summer Institute program possible here at UD, and to the Bais lab for their support.